Hello everybody, my name is Ali and welcome to my AI scene. The criteria is to develop a software application demonstrating the path planning abilities and simulate, represent, and implement intelligent behaviors of virtual agents within the context of a computer game, making use of appropriate AI patterns. In this video, I will be talking about what my game scene is, the research I undertook for this project, the different features in the scene, and finally, a critical analysis of those features. So let's get started. The computer game scene I set out to do was create a city environment to create a paparazzi AI that searches for celebrities by traveling from one place to the next, inspired by a side story in GTA 5. The research done for this project is mostly from Class Labs, the Sebastian Lake A-Star Pathfinding playlist, and looking at other colleagues' AI scenes and getting inspiration and ideas from them. I also used resources from Learn Unity website. I used Unity Engine for this project. Inside the game engine, I first implemented the A-Star pathfinding algorithm using grid and node-based calculations to find the most efficient path from point A to B while avoiding the obstacles defined by the unwalkable layer mask. I improved this algorithm by adding heap optimization so that runtime performance could be increased. I expanded this further by adding cost using layer masks, meaning certain areas cost more to traverse and NPCs can find cheaper paths to their destinations. I did succeed in converting the grid from 2D to 3D. However, the issue was that the NPCs were now finding paths in the sky and underground. After attempting to fix this issue using rigid body constraints and debugging in the script, I unfortunately had to revert back to the 2D grid. Once AI was implemented, I also added breadth-first search as a non-uniform pathfinding system. After pathfinding, I worked on creating a finite state machine. This was for the NPCs who would be using the A-star and breadth-first search algorithms. I started by creating the basic states of finding a destination, walking to that destination, and finally waiting at the destination. The states then repeat. The issue came when trying to move NPCs using the generated path because they would iterate through the nodes of the path so quickly that the NPCs would not have reached the first node and they would be attempting to move towards the final node. To solve this issue, I changed the pathfinding script to take in a single node from the list of nodes, and instead of iterating through the list, the walking state was only passing in the first node. Once the distance to the first node was less than 2, it then changes state, removes the node, checks if the node list is empty. If it is, goes to the waiting state, otherwise goes back to walking state to move towards its next node. This state cycle can be broken by 3 things. The first is the stamina of the NPC, which drains every time it walks and increases when it's standing or waiting. When the NPC gets their stamina below 20, it switches states to the go to the park state, which sets its destination to a park so it can recover stamina. Once at the park, it goes to the at park state where it gains stamina faster than just standing. The second is when the NPC gets hit by a car. The NPC dies in the dead state and is destroyed. The last interruption is when the player interacts by pressing the E key when near it, which then sends the NPC to the talking state where it tells the player something and starts walking again. The path planning system of this NPC is non-deterministic as it chooses between A-star and breadth-first search on its own and uses that path planning system. This FSM is a hierarchical state machine using object-oriented paradigm with the 3 base states of walking, waiting, and finding destination being a loop which gets interrupted by either a car, the player, or their stamina. The crowds in the city are all using this state machine. After finite state machine, I added some stagnant NPCs into the world to make it more lively. These NPCs stand in a spot and the player can interact with them by talking to them however long the player wants. Once that was done, I moved on to behavior trees. The plan was for this to be used for the paparazzi and celebrity. Instead of creating a visual-based behavior tree, I implemented a code-based behavior tree with its own sequence and selector nodes and conditional branches like repeat, if, and while. The celebrity and paparazzi both use ray bundle sensors to detect each other. The celebrity behavior tree starts by checking if the paparazzi is in range or hitting the ray bundle vision. While it's not, it finds a location and starts moving towards it using breadth-first search. The same logic has been applied to the behavior trees from the finite state machine to move the paparazzi and celebrity. If the paparazzi is detected, the celebrity avoids the paparazzi by stopping and looking at the paparazzi, then turning around and moving 10 steps forward in an attempt to run away. Once it no longer detects the paparazzi, the first sequence is executed again. Once the celebrity reaches its destination, it waits for 10 seconds before moving away to a new destination. The paparazzi behavior tree is slightly different, where it checks if the celebrity is in range. If not, it goes to a given location using breadth first search. It does the same checks as the celebrity behavior tree. Once it does detect a celebrity in its rain bundle sites, it pursues as it stops what it's doing, looks at the celebrity, and moves towards it. However, it is not fast enough to catch up, so loses sight and returns to the first sequence. The difference in this behavior tree is that if the paparazzi is in range of the player, it stops and talks to the player automatically, unlike the finite state machine, where a key is needed to be pressed by the player, and this interaction can be interrupted if the paparazzi spots a celebrity in its path. The paparazzi and celebrity have a complex behavior tree, as the behavior tree is able to handle different interactions. The issue I was having of creating two behavior trees with almost similar things to do, I solved it by creating a behavior tree class and people class and inheriting them in the celebrity and paparazzi class. Once the behavior tree was finished, I moved on to goal-oriented action plan. I wanted to add a car into my city that would go around, pick up a NPC, and take it to its destination. I ended up with a basic implementation of the taxi going around the road. The interaction with other NPC it has is that it stops when it detects any NPCs or players in its path, and sometimes accidentally hits them and the NPCs die. The player has movement and a stamina bar, just like the FSM NPCs. It drains when walking and drains faster when running. To recover stamina, the player needs to stand still. The player can interact with the finite state machine NPCs, the paparazzi, and the stagnant NPCs. For steering behaviors, the celebrity has an avoid behavior with the paparazzi, and the paparazzi has a pursue behavior with the celebrity. Apart from that, there are also birds flocking with separation, cohesion, and alignment all working together. Each of the different actions have sound and animations that go with it. There is car horn, birds chirping, wind, footsteps, talking, and waiting sound. Lastly, debug information has been added into the world to show NPC state and stamina, and player stamina alongside grid and node debug has been added. And now here is 1 minute of uninterrupted gameplay. For the strengths of my scene, I have a lot of features and a lot going on in the scene, with players and NPCs interacting. The BOID behaviors are pleasing to see and the city looks good. As for the weaknesses, the world doesn't have a main part to focus on. A lot of the features are unpolished and could do with more work on robustness. The player sometimes enters the jump animation due to uneven terrain, and GOAP Taxi needs to have a purpose rather than just going around hitting NPCs. I would be working on the bugs mentioned above, alongside adding in new features such as birds being able to land on ground because of stamina loss, and the player not being controlled but instead a machine learning AI controlling it. That's it for this video. Thanks for watching.